Welcome to the Explainer. Today we're powering up and diving deep inside your PC to uncover one of those little details that really separates a good power supply from a great one. And believe me, it's a tiny component with a huge story.
You know, when you're out shopping for a new PSU, it's so easy to just look at the brand name or that big wattage number on the box. But the real story, the stuff that actually tells you about quality and reliability, is almost always hidden inside. All right, so let's kick things off with something that might surprise you. Not all power supplies from the very same brand are created equal. No way! You can have two units, same company, that perform wildly differently, and it all comes down to what's happening under the hood.
The secret here is something called the PSU platform. And the easiest way to wrap your head around this is to think about a graphics card, right? You can get a card from MSI or Gigabyte, but if they're both built around the same core NVIDIA GPU, their fundamental performance is going to be super similar. Well, the platform is that core architecture for the power supply.
And that's really the crucial point here. While the brand name is on the box and gets all the attention, it's that hidden internal platform that truly dictates everything, from performance to how long the thing is actually going to last.
So, how in the world are you supposed to judge the quality of that internal design without, ripping your power supply apart? Well, it turns out there's one tiny little component that acts as a huge telltale sign. We are talking about the capacitor. Seriously, you can think of these things as the kidneys of your power supply. Their whole job is to filter out all the electrical junk and noise coming from your wall outlet so they can deliver clean, stable power to your really expensive and very sensitive components like your processor and your graphics card.
But just like the power supplies themselves, not all capacitors are the same. Not even close. And that's where we get to that gold standard you always see advertised on the boxes of high-end PSUs.
It really all boils down to temperature. Your standard run-of-the-mill capacitors are often rated for about 85 degrees Celsius. But these much more robust Japanese-made models, they can handle a blistering 105 degrees. And trust me, that 20-degree difference is a much, much bigger deal than it sounds. The difference in durability is just staggering. A high-quality Japanese capacitor, say from the Rubicon ZLH series, is rated to last for up to 12,000 hours running at its absolute maximum temperature of 105 degrees. Now here's where it gets really crazy in the real world. A standard cap might be rated for 2,000 hours at 85 degrees, but stick it inside a hot PC case running at 100 degrees, and its lifespan absolutely plummets. We're talking less than 200 hours. A Japanese cap, on the other hand, running at a cool 85 degrees, can last for over 50,000 hours. They're just built to endure. And it's not just about heat. There's another critical factor, something called equivalent series resistance, or ESR. Just think of it like electrical friction. It's a measure of the capacitor's own internal resistance. The lower the ESR, the more efficiently it does its job. And, as a bonus, the less waste heat it generates. So, Japanese capacitors typically have 30 to 50% lower ESR, and that is absolutely crucial for filtering out the high-frequency electrical noise, the ripple, that modern power-hungry GPUs are constantly creating. It means they get the cleanest possible power, which is exactly what you need for maximum stability.
This kind of superior performance doesn't just happen by accident. It comes from an almost obsessive level of quality control. Japanese manufacturers often follow automotive-grade standards, putting these things through brutal tests for heat, humidity, vibration. They even analyze how they fail just to make them safer.
This chart here really just puts it all together. You can see that clear advantage right across the board. They're stable at high temps, where standard caps are just barely hanging on. They have low ESR for that clean power versus the high ESR and, well, noisy power from standard caps. And their whole design philosophy is built for high-power, long-term use, which is exactly what you need to protect your gear for years. Okay, so all these technical specs are impressive for sure. But what does it all actually mean for you and your expensive gaming rig or workstation? I mean, why should you even care? Well, it all translates to real, tangible benefits. It means better protection for your most valuable components. It means more stability during those intense gaming sessions and fewer mysterious crashes. And it means long-term reliability that can easily last you a decade or more. Ultimately, it's all about giving you peace of mind. It's that confidence you get knowing your hardware is being protected from the silent, invisible threat of dirty power. Not just for a year or two, but for the entire life of your system.
So let's bring this all back to when you're buying your next power supply. Why does this one tiny spec matter so much in the grand scheme of things?
You know, in the PC building community, this idea has basically become a trusted rule of thumb, and for a really good reason. It's a reliable shortcut for spotting a quality unit because the decision to use these more expensive parts, well, it says a lot about the manufacturer's entire philosophy. Seeing 100% Japanese capacitors on a box is not just marketing fluff. It's a powerful signal. It tells you that the manufacturer chose not to cut corners on one of the most critical yet hidden components. And if they're not cutting corners there, chances are they're not cutting corners on the rest of the unit either.
It's a fantastic shortcut for identifying quality in a really complex product. And that leaves us with a final thought to chew on. What other small, hidden specifications might be telling a much bigger story about the quality of the tech you use every single day?